In this lecture, we are going to see on how we are going to construct the confidence interval for a parameter of a population based on the statistic of a given sample. Suppose that under the hypothesis H, the sampling distribution of the statistic S is a normal distribution with mean mu s and standard deviation sigma s. Then the standard normal variate associated with this statistic S is given as Z is equals to S minus mu S over sigma S, where this normal distribution of Z has a mean of 0 and a standard deviation of 1. Suppose a population random variable X has the parameter whose value is unknown. From a random sample of size n, the value of the statistic S can be used to estimate the parameter at a Z% confidence level. As probability of the parameter lying at a distance of E from the statistic S to be equals to gamma, or gamma is equals to Z%, wherein gamma will be lying between 0 and 1. Then we consider the closed interval S minus E, S plus E as a random Z% confidence interval for the required parameter, and E is called the margin of error. This means that the probability is gamma that a random sample will result in a value S for which the numerical interval S minus E, S plus E contains the required parameter. The parameters which we do want to estimate are mainly the population mean mu and the population proportion P. So let us say that gamma is the specified confidence level such that gamma lies between 0 and 1. The confidence interval for the estimation of mu would be followed in 3 steps. The first step is first we will be finding the critical ZC value such that the probability of Z lying between minus ZC and ZC is equals to gamma. Next, we will be estimating the margin of error given as E is equals to ZC into sigma x bar, where sigma x bar is the standard deviation of the sampling distribution of the means, which is again in turn given by as ZC into sigma divided by root n. Next, we will be finding the confidence interval for the existence of the mu as x bar minus E, x bar plus E, where x bar is the sample mean. Then the confidence interval for the existence of the population proportion P, again we will be finding the critical ZC value for which the probability of Z lying between minus ZC and ZC is equals to gamma. Then we will find the margin of error, E is equals to ZC into sigma P, where sigma P is the standard deviation of the sampling distribution of proportions, which in turn is given by ZC into square root of P times 1 minus P divided by N, where capital P is the proportion of success in the sample. Then the interval of existence of the population proportion is given by P minus E, comma P plus E. Next, we will look at some problems wherein we will be finding the confidence interval and the margin of error. So let us have this first problem. Suppose x is a normal random variable with mean mu, which is unknown, and standard deviation sigma, which is known to be 2. A random sample with replacement of 25 values of x result in a sample mean of 10. Determine the margin of error E for a 95% confidence interval of mu and find the corresponding confidence interval. So first let us write down what are given. Sigma is given as 2. The sample size is given as 25. The sample mean x bar is 10. So here we need to determine the 95% confidence interval. That means probability of z lying between minus zc and zc is equals to 0.95. And we have seen that the critical value for 95% confidence interval is, so here we expect that 95% of the scores of the normal distribution lie in this region. So we have seen that the critical value for this is 1.96. So therefore this implies zc is equals to 1.96, and we have E to be equals to zc into sigma x bar, which is zc into sigma over root n, which is 1.96 times 2 over root 25, which is found to be equals to 0.784. So this is the error which we can expect at a 95% confidence interval for existence of mu. And the confidence interval is given as x bar minus E comma x bar plus E, which is found to be equals to 9.216 and 10.784. So the probability that mu lies in this interval is 95%. Here is the second problem. Suppose x is a normal random variable with mean mu, which is unknown, and standard deviation sigma, which is known to be 2, and we wish to obtain a 95% confidence interval for mu with a margin of error no longer than 0.5. How large must the sample size be? So they are asking us to find what is n. Given sigma is equals to 2, E to be less than or equals to 0.5, and we are asked to find what is n. At 95% confidence interval, we have probability of z lying between minus zc and zc to be equals to 0.95. So this gives us the critical value of zc at 95% confidence interval is 1.96. We know that E is given by zc into sigma x bar, which is zc times sigma over root n, which is 1.96 times 2 over root n. They say that E should be less than or equals to 0.5. So this implies 1.96 times 2 over root n to be less than or equals to 0.5, or this implies root n to be greater than or equals to 1.96 times 2 over 0.5, or this implies n to be greater than or equals to 7.84 the whole square, or this implies n to be greater than or equals to 61.5, or we can approximate this as n to be greater than or equals to 62. Here is the next problem. A population random variable x has unknown mean mu and standard deviation sigma equals to 20. A random sample of size 100 results in a sample mean x bar equals 250. Find the corresponding 90% confidence interval for mu. So here first we will write down what are given. Sigma is 20, n is 100, x bar is 250. At 90% confidence interval, we need to have that the probability of z lying between minus zc and zc to be equals to 0.90. So this implies the critical value is equals to 1.65. Now let us find the margin of error, which is given by ZC into sigma x bar, which is ZC into sigma over root n, which is equals to 1.65 times 20 over square root of 100. So this gives us E to be equals to 3.3, and the confidence interval is given by x bar minus E, x bar plus E. So this gives us 250 minus 3.3 comma 250 plus 3.3, which gives us 246.7 comma 253.3. So the confidence interval for the mu is 246.7, 253.3. The next problem is as follows. In a random sample of 900 registered voters, 55% favor the Democratic candidate for president. Find an appropriate confidence interval for the proportion of all registered voters that favor the Democratic candidate at confidence level 90% and 99%. So first let us write down what are given. So n is given to be equals to 900. Then the proportion of the candidates who support the president is capital P, which is equals to 0.55. And at 90% confidence level, the critical value is given by 1.65. The error is given as ZC times sigma P, which is ZC times square root of P times 1 minus P over N, which is given as 1.65 square root of 0.55 into 0.45 divided by 900, which gives the value to be equals to 0.03. So the confidence interval at 90% would be equals to P minus E, P plus E, so which would be equals to 0.55 minus 0.03, 0.55 plus 0.03, which gives us the interval to be equals to 0.52 comma 0.58. Similarly, at 99% confidence level, ZC is given by 2.58, and using the formula, E can be calculated as 2.58 into root of 0.55 into 0.45 over 900, which gives approximately 0.04. So the confidence interval would be P, which is 0.55 minus E, which is 0.04 comma 0.55 plus 0.04, so which gives us the interval to be equals to 0.51, 0.5.